Alright, so next we're going to look at one of the big pieces here, which is the trig ratios. Again, these trig ratios must have a right angle triangle, and now the angle we refer to as theta. We would have seen that before. In this diagram, it's going to be an acute angle, by the way, because again, if this is 90, these are going to be combined less than 90 as well. So that's just something to keep in mind. And we'll see the symbol before when we was doing measurements, perimeter area and volume, when we had the length of the arc, the area of the sector. We call that unknown angle theta, because that's generally what we call an unknown angle. So me referring to it as xyz before, here now we'll be referring to it as theta. Alright, not to confuse it with length. So that's what we'll normally use for our unknown angle. So we need to give the sides names. We already know opposite the 90. We call that the hypotenuse. We came across that before. But I'm gonna write out the full name. We'll shorten it with HYP or just H, right? Because it's a long word to write out all the time. With respect to the angle though, we're not going to call this height and base. We're going to get two new names. So wherever the angle is, whatever angle we decide we're using, it cannot be the 90. The 90 is just to let me know it's a right angle triangle. So what angle we decide to use, to be either this one or that one, or the question will tell me I have to use that one depending on the information I have. Opposite that, so if I draw a line to the next side, just like we was doing with the isosceles triangle, opposite this angle, we call this side simply enough the opposite side, or OPP or O, depending on how much you want to write out. The remaining side actually touches the angle. Now again, the angle could be here, meaning the opposite side is going to be that side, and this side is going to be touching the angle. You'll realize that when we're doing some more later. So the remaining side actually touches the angle. So one side that we're going to name far from the angle, in fact it's on the opposite side of the angle, so we call it opposite. The other side will be touching the angle, and a fancy word that we use for touching or near to is adjacent, or A, or ADJ. So these are the new names we use when we doing the trig ratios, and the trig ratios, just to introduce them to you, although you'll probably come across it at some point before. So the trig ratios will be used to calculate either the length of a side or the size of an angle. If you're going to use the length of a side, we have three options. We have sine of the angle, theta. We have cosine, which we shorten with cos theta. And then we have tangent, which we shorten with tan theta. Now each one of these, we call it a ratio because we're going to use a different combination of these. So sine is the opposite side over the hypotenuse. Those two lengths go together. Cos is the adjacent side over the hypotenuse. And tan is the opposite side over the adjacent side. Now you don't have to worry too much about remembering these, because if you forget, this actually on the formula sheet. So if I forget, these there on the formula sheet as a guide to help me remember, and these are what we use for lengths of side. Realize how it starts off, sine theta opposite over hypotenuse. And by the way, these are just buttons on your calculator. If you look at any calculator, and this is why I keep stressing, you get accustomed to your calculator, sine, cos and tan are buttons on my calculator, actual physical buttons. If I want to find the size of an angle, which is also something that these formulas can do, the formula going to change slightly though. Our angle is theta, so instead of saying sine theta, we have to actually start off with theta. So for all of these, it will be theta, and it will just be the inverse, very similar to what we was doing with functions and finding the inverse. This is also a function, and we find the inverse of that value. So sine inverse, opposite over hypotenuse, cos inverse, opposite over, adjacent over hypotenuse, ADJ, right? And tan inverse, opposite over adjacent. So it's the same ratio, it's just using a different button on the calculator. And if you watch on top each of the buttons on the calculator, you see in the sine inverse, cos inverse, tan inverse, and to access that is shift for second function. Again, this is why it's important for you to know how your calculator works. So let me see how this actually works. So if you want to find the length of the side, these are what we're using. They're giving me this on the formula sheet. They're not giving me these on the formula sheet. You're responsible for these, but if you notice, it's the same ratio It's just a different button on my calculator I'm pressing, right? That's just something to keep in mind. Let me look at the example because the example should explain it a little better. I want to calculate the length of x, of side x, right? Sorry, I didn't put in which side x was. This is x in this one, sorry about that. So the first thing I have to do, just like with Pythagoras' theorem, which is the other rule that only works for right angle triangles, I need to label my sides. So opposite the 90, this is the hypotenuse. That's the easiest side to label. The next easiest side to label is the opposite, because the way we get the opposite, once I have an angle, I just draw a line to the next side, and that side, far from the angle, it's opposite to the angle, so that's how we call it the opposite. And the remaining side, just double check, yes, it is touching the angle, we call that the adjacent. So I want to calculate the length. You realize we can't use Pythagoras this time, because in order to use Pythagoras, I have to have two sides in order to find the third side. Here we only have one side on an angle. So you realize how the angles coming into play here as opposed to Pythagoras where we had no angles. So which ratio I'm going to use? So since I want a length, these are the ones we're looking at. We don't want an angle yet. So I have to use one of these. Now I can't just pick and choose which one. The question actually going to tell me which one I have to use based on the information I have. So let's look at what we have. So in this question, what did they ask for? What do they want? They want the length of side x. This is side x, and right now side x is the adjacent. So in maths, if I want to find for something, the only way I could find for it is if I use it. So I need to use the adjacent side, which is x. And I want to stick something into one of these ratios, these formulas then. So which one will be better? Opposite that not, they didn't ask for opposite, they didn't give me no numbers for opposite, or hypotenuse where they give me 10 for. So I need information to put into my question. It don't make sense having two things I don't know, because I want to solve for one thing at a time. So these are the two that makes the most sense to use. They asked for this, so I have no choice. I have to use the adjacent side, which is x. And since they actually give me a number for the hypotenuse, I'm going to use these two pairs. Which one of these formulas using these two pairs? So it was, again, just to refresh your memory, adjacent and hypotenuse. So opposite and hypotenuse, opposite and adjacent. This one using adjacent and hypotenuse. So once I figure out which ratio I'm using, based on the question telling me I have to use that, I don't have a choice in the matter. I have to use cos theta is the adjacent side over the hypotenuse. First part, I figure out which ratio I want to use based on the information that the question give me. So the next part now is substitute, because I have a formula. This is the formula I'm going to use. Let's substitute. So cos of the angle, we actually have a value for the angle this time. Theta in this case is 60 degrees, is equal to the adjacent side. What's the adjacent side? The adjacent side is x, and the hypotenuse is 10. So we replace everything. And now I just need to solve. So the easiest way to get rid of a fraction, because this is what I have here, is to cross multiply. So I'm going to cross multiply. So what I'm going to end up with when I cross multiply, again you're realizing it's algebra, I'm going to get 10 times cos 60, now the 10 have to come in front, times cos 60, but when letters close to numbers, I don't really need to write that multiplication sign to be understood if I just write 10 cos 60, by the way. Understood that it means multiply there. And on the next side I have 1 times x, which is just x. So I find x. This is what x is. And that's where my calculator going to come in handy. And you're allowed to use your calculator for this. So I'm just going to put in 10. Sorry. I'm going to put in 10. I press my cos button. I press 60. And I get my answer. My answer is 5. So the answer for this length is 5 meters. Which makes some sense because it has to be less than 10, 10 being the hypotenuse. And that's it. I find my answer. Let me go through the procedure again with a next example. Again, the orientation of the triangle could change, the position of the angle could change as well. So let me look at this one here. So the first thing I'm going to do, I realize I can't use Pythagoras because they give me a side and an angle, and they want to find in all of these the length of side x. So I'm going to label my sides. Opposite the 90 degrees is going to be my hypotenuse, so h. Opposite the 50 degrees, which is the next piece I'm doing wherever the angle is, I draw a side to the opposite, and the last side going to be touching, and that side going to be the adjacent. The adjacent is the hardest for most students to get, so that's why we leave it for last, and then you double check it, right? So first part finished, I label. Second part now, which one of these ratios I want to use? Again, I don't have a choice in the matter. It's going to tell me based on the information. So let's see what information I have. They want to find x, so I have to use this side, which is the opposite, and they give me the 7. The hypotenuse have no role to play in this question. So I'm looking at opposites and adjacent. So opposite and adjacent means I'm using tan for this question, because tan using opposite and adjacent. So I find the ratio that I have no choice but to use. Tan theta would be, and I write it down, opposite over adjacent. I'm starting to shorten it a little more instead of writing out the longer form. And now I substitute. So tan, the angle is 50 degrees. The opposite side is x. The adjacent is 7. And just like before, I want to get rid of the fraction, so I'm going to cross multiply. So I'm making both sides fraction. Bottom of one side to the top of the next. Bottom of one side to the top of the next side. So I'm going to get 7 times tan 50. So again, I don't need to write the multiplication sign here. Just like I don't need to write 1 times x. 1 times x is 1x. So again, this is my answer, and I just stick it in my handy calculator. So 7 tan 50, you see how I'm doing it? I just press 7 tan 50 equals, and the answer pretty long. So normally in these questions they ask you to shorten it to 1 decimal place, to 2 significant figures. That's where your approximations will come in. We will leave this for now as 1 decimal place. So 8.34, 1 decimal place. The next number after the 3 is less than 5, so it will remain as 8.3 meters. So whatever the units are for the question. So this is 8.3 meters. And that's it. That's how we do it. And we do our next one again. You realize for this one, I'm just showing you the different variations. The angle in a different position. All the time the angle is on the bottom. Let me see if it will make a difference with the angle on the top. So I'm going to label my sides. Opposite the 90 is the hypotenuse. Opposite wherever the angle is, this time the angle is here, so opposite that side, I draw a line to the next side. This side is the opposite, and the remaining side actually touching the angle. You should double check that it is. That's the adjacent. Now it's time to decide which ratio I'm going to use based on the information I have. They asked for x, so I have no choice. I have to use this side. And which one give my number? The 12 is the hypotenuse. So I'm using again opposite and hypotenuse, which was the last one we didn't. I want to use all just to make sure you see all of them. This one is sine. So sine theta will be the opposite side over the hypotenuse. And now I substitute into my formula. Sine, the angle in this question is 25 degrees. The opposite side is x. The hypotenuse is 12. Just like before, you realize it's the same pattern all the time. I cross multiply to get rid of my fraction. Bottom to the top of the next side, bottom to the top of the next side. So I get in 12 sine 25 is equal to 1 times x, which is x. And then that's where my calculator come in again. This is my answer, 12 sine 25, because I have x. 12 sine 25. When I type it in, again, is the next long answer, 5.07. I wanted it to 1 decimal place. So this is my 1 decimal place here. So I look at the next number is 5 or more. So here I need to increase by 1. So my answer is going to increase from 0 to 5.1 meters. And that will be my answer for x. Any questions so far? Let's see. Again, we're just looking at some different examples, and eventually I would want you to try for yourself. So in this next one, you realize the orientation change again, because the triangle will always look nice and upright like this. You could have the orientation change. Same idea. Opposite the 90 is always the hypotenuse. Wherever the angle is, I draw a line to the next side. That is the opposite, and the remaining side have to be touching the angle actually resting on that side. That's going to be the adjacent. So let me see which ratio we're going to use for this one. They ask for the opposites. They give me the adjacent. So opposite and adjacent, you could check back the front. That's going to be tan of the angle. Opposite over adjacent, and then you just substitute. Once you have your formula as your guide, the angle is 40 degrees. The opposite side is x, the adjacent side is 9, and again, you realize it's a pattern. We do the same procedure each time, cross multiply when I reach this step. So I get to 9 times tan 40, 1 times x, x. And then I just stick it in. Just one thing I forget to mention, your calculation should be on the degrees setting. It should have a D or a DEG there. And in some calculations, it could change easily because it have that button DRG. So if it's not on degrees or D, you find the button to make sure it's on degrees. So you just reset it in the back. Have a button on the back to make sure. The default is in degrees. Because if it's not in degrees, then you might get the right answer if you calculate on a different setting, be in radians or gradient. So just make sure it's on DEG. So for this one, 9 tan 40, 9 tan 40, 7.55. Again, I want to round it off to one decimal place. That 55 will round up to 6 because it's 5 or more. So that'll be 7.6 meters, and that'll be my answer. So looking straightforward so far, but let's look at one variation that could come up. And that's this one. It looks exactly like the others, but let's see what slight difference this one going to have on it. Just like before, label my sides. Opposite the 90 is the hypotenuse. Opposite the angle is the opposite. And the remaining side actually touching the angle, that'll be the adjacent. Let me label my sides. That's done. Highlight what I have. They want to find x, so I have to use that. They give me the 4, so I'm using opposite and hypotenuse, which is sine. Everything looking normal so far, right? And now we substitute. So the angle is 30 degrees. The opposite is 4, and the hypotenuse is x. So even though it might look the same for the first time today that we're looking at, x now on the top. All the questions we look at so far, I hope you realize x was on the top. X was on the top. I know it might look like a small difference, that x on the bottom. The only difference now is I still have to cross multiply. When I cross multiply, I'm not going to get that nice neat answer I had before, because now I'm going to get x sine 30. And now I'm going to get 1 times 4, 4. And the problem is I could only solve for x if x by itself. X is not by itself, so I have an extra step of working to do. And my step of working here is to get x by itself. Right now, x multiplying by sine 30. I need to get rid of that multiply by sine 30 so x could be by itself. So in maths, to get rid of anything, you just do the reverse of it. So if I want to get rid of multiply by sine 30, the reverse of multiplying by something is to divide, and you just divide by the same thing. And let me just demonstrate this with a different example. We will go through this before. So if I had x plus 2 is equal to 5, we all know x is 3, but what we're really doing, if I wanted to get rid of plus 2, the reverse of plus and 2 would be to minus 2, and whatever you do to one side, because I add in this minus 2 here, I have to do to the next side. Plus 2 minus 2, because once I do the reverse, that piece is going to disappear. And I remember 5 minus 2, which is 3. And I would have showed you this before, so that's why we say it looked like we carry this across and the sign changed, but what we're really doing is the reverse of adding 2, which is minus and 2, and what you do to one side, you do to the next. Same thing if I was to multiply. If I had 2x is equal to 10, right now 2 multiplying by x to give me 10, and I want x by itself. So what would the reverse of multiplying by 2? Dividing by 2. And what you do to one side, you do to the next. So these 2 is going to cancel off or turn to 1. So it come like it disappear, and I get 10 divided by 2, which is 5. This is just a harder version of that same simplistic idea. I want to get rid of multiply by sine 30. The reverse of multiplying by sine 30 is to divide by sine 30. And whatever you do to one side, because this wasn't in the original part, that divide by sine 30, to keep the equation balanced, I have to divide this side by sine 30 as well. So what's going to happen is, anything over itself going to cancel out. So what I really remain with is x is equal to 4 divided by sine 30. And when I say 4 divided by sine 30, I just put in my calculator 4 and I divide it by sine 30. That's basically what I had there with the division sign in place of the slash. And I get my answer as 8. And that's my answer. X going to be 8. Let me see if that makes sense. Mathematically, it does make sense because the hypotenuse is supposed to be the longest side of the triangle. So I expect my answer to be more than 4. If I had multiply out, I get 2. So obviously the hypotenuse cannot be less than 4. It has to be longer than 4. So those are the different variations you would get. And just like we did with Pythagoras, it have 2 questions here. I want you to try it yourself. I'm just going to help you out with the first one as a guide. Opposite the 90 is the hypotenuse. Opposite the angle will be the opposite side, so the remaining side going to be the adjacent, and now use that information to decide which ratio you're going to use. And when you try it, see if you get any 6.2. Same thing with this one. Label the sides, circle or highlight what information they give you and asking for, and from that you'll use that to get your answer, and you'll see what it's looking like. So one more I really didn't get to look at was the size of the angle. Right, so for the size of the angle, I now realize I went well over the time limit for this question here, but we'll see if we can sort that out and split it into two videos. So for the size of the angle, same idea. Opposite the angle is the hypotenuse. The 90 degrees, sorry, we're calling the angle theta because it's an unknown angle this time. So opposite this angle would be the opposite, and this will be the adjacent. So now, just like before, they give me both the opposite and the adjacent. Hypotenuse have nothing to do with this question. So opposite and adjacent means we're going to use tan theta equal opposite and adjacent. But I can't use that because they actually want an angle this time. And because they want an angle, these are what we use for angles. So even though we're using the same ratio, we have to rewrite it as the angle as the focal point there. So theta will be tan inverse opposite over adjacent because I wanted an angle. So it will be tan inverse, which is just a different button on your calculator. Opposite is 3 divided by 4. So the angle, and again I'm just going to show you on my calculator there. So it will be second function, because to access anything on the body and not the button, the orange is going to refer to the orange. So second function, tan inverse. You see tan inverse come up. Open my brackets, 3 over 4, 3 divided by 4. You could use your fractions button, however you want to write it. That's exactly what this means here. And the angle to the nearest degree, because the angle is really small, to the 6.8, going to round up to 37 degrees. And that's what this angle is going to be inside here. It is a acute angle, as you can see. And we'll see more of these when we're looking at some past paper questions a little bit later.